Hello, and a very warm good evening to all of you. Today, we are here with yet another exciting, interesting session of our education series at UinDhi. And I'm all the more thrilled to host this session because today we have with us two extremely talented, fairly young mathematicians, researchers, who also happen to be my colleagues, Dr. Subhrajit Dey and Mr. Shubham Mukherjee. They will be jointly presenting today and enlightening us on the beauty of mathematics spread across our lives. Dr. Subhrajit Dey did his formal degree in mathematics from Barasat Government College and West Bengal State University, where he was the gold medalist of his batch in 2015. Later, he joined IIT Hyderabad for a short-term project. In 2017, he joined Muralidhar Girls College as assistant professor of mathematics. He continued his PhD studies at Jadavpur University and was awarded the degree of PhD on 17th May 2023. In the course, he has published several research articles, out of which two of his work is worth the mention as they were published in the prestigious Linear Multilinear Algebra Journal of Mathematics. He is also deeply spiritual and follower of Thakur Sri Ramakrishna, Sri Sharada Devi and Swamiji's teachings. An active member of the Akhil Bharat Vivekananda Yuva Mahamandal, he swears by Swamiji's teaching, education is the manifestation of perfection already in men. We are extremely honored to have you with us today here. Thank you so much, Dr. Dey.
Thank you so much.
Next, our speaker is a very young, dynamic, and enthusiastic mathematician, Mr. Shubham Mukherjee. He completed his formal education and from the University of Calcutta and later from West Bengal State University in 2019. He is the receiver of Swami Vivekananda Merit Scholarship and Vidyashree Award for his exceptional academic performance in secondary and senior secondary levels. Currently, he is working at Muralidhar Girls College as a guest lecturer of mathematics. At such a tender age and early in career, he already has published several book chapters. He is also a wonderful, talented sarod player as well as a great singer. It is our great pleasure and honor to have you with us here today, Mr. Mukherjee. Thank you so much.
Thanks a lot.
Without further delaying this session, I'd leave it on to both of you. Please go ahead with the session.
My sincere gratitude to all the members of this social networking platform, UinDhi, of some creative, energetic, and definitely spiritual minded personalities for giving me these opportunities. It's a great honor for me to deliver a short lecture in this wonderful platform. First of all, I would like to say that the statements about me said by Priyadi is only the reflection of her affection to me and also for her gratefulness. Many times, in many aspects, I got so many help from Priyadi for the last few years. To me, she is a source of inspiration and I cannot admire her with some words only. Next, I must say about Mr. Shubham Mukherjee. To me, Shubham is like a removal of any difficulty. When Priyadi asked me to make a presentation, I was totally unprepared how to start. Then I requested Shubham and very quickly he made a pillar of this presentation and then on discussion with him, we together represent it. So I heartily acknowledge Shubham and I must say there is no doubt that without the help of Shubham, it was not possible to stand such a beautiful presentation. Let's come to the point. The lecture is about the daily life application of mathematics. And also, since this is a spiritual platform, lifting some connections between mathematics and spirituality may glorify this lecture. So our first slide will involve slightly uphold that. I am starting the presentation, and for first few slides, I will be there, and then I will hand over Shubham. Shubham will end the session. So the topic of our presentation is beauty of mathematics in numerous aspects. And since I said that there should be a connection between spirituality and mathematics, so for the first two slides consist this. So this is some connection between mathematics and spirituality. Spirituality in the context of Indian scriptures is a deeply ingrained and multifaceted concept with various interpretations and perspectives across different philosophical and religious traditions. Atma and Brahma. In many Indian spiritual traditions, spirituality revolves around the concepts of Atma and Brahma. Atma is the individual soul or self, and Brahma is the ultimate, unchanging, and infinite reality or universal consciousness. True spirituality, according to Indian scriptures, involves recognizing the oneness or unity between one's individual Atma and the universal Brahma. Achieving this realization is often described as the primary goal of human life. So, for this, from the starting of mathematics, first we have learned that what is natural numbers. So we all know that natural numbers are 1, 2, 3, 4 up to dot dot infinity. So as a mathematics student, we should not write like this up to infinity. That is actually correct should be 1, 2, 3, 4 dot dot. We should keep in mind that infinity is not a number. In fact, it is not a natural number. It is a sense. And see here, we cannot reach to this infinity by our finite mind. As if you tell me a very large number like 10 to the power 10, surely I can give you another number what is larger than 10 to the power 10. What is that? That should be 10 to the power 10 plus something, 10 to the power 10 plus 1. So, in this manner, if you give me any large number, I will give you another large number larger than that. So, in this manner, we cannot think to the last natural number and cannot think to reach there. Now, the strange is that the very, very large number just said is a very, very small number with respect to our infinity. Because if we say that a number 10 to the power 10 to the power 10, then this 10 to the power 10 will be very smaller respect to this 10 to the power 10 to the power 10. So, studying infinity can prepare our mind to reach that supreme God and also give an insight about the limit of our I. The limit means first we are saying that 10 to the power 10 is a very large number, and now it is proved that this is the limit of our I, and this is not true because there is more larger number. So it is very clear that to understand supreme, to understand God, to understand Atma and Brahma, we need to understand first the concept of infinity. Next, we give some examples that mathematicians really think about these connections. So, mathematicians on spirituality. From ancient times, many mathematicians said so many quotes which make us think the connection between the spirituality and mathematics. Leopold Kronecker was a German mathematician who worked on number theory and algebra. He said in a lecture that natural numbers were created by God. Everything else is the work of men. So, one sentence is enough for this motivation. Then Ramanujan, who is the inspiration of all mathematicians. Ramanujan said that an equation means nothing to me unless it expresses a thought of God. So, I will not lengthy this lecture by saying his contribution to mathematics. One sentence to understand that is enough, that Ramanujan's birthday is celebrated as the National Mathematics Day, that is 22nd September. He used to play by the numbers. And from this stimulating motivational quote of Ramanujan, surely we can expect that Ramanujan would want to get spiritual touch from each object of mathematics. And these discussions about connection of mathematics and spirituality may continue at least 24 hours, and I should not continue further. Let me go to the next topic. And here we are not entering in the hardcore mathematics. We just want to exhibit some simple mathematical applications. So first, see the application of discrete mathematics, actually congruence operation in ISBN number. What is ISBN number? Every book has an ISBN number, International Standard Book Number, that is a unique number that is assigned to every published book. And ISBN identifies the book's edition, publisher, and physical properties like trim size, page count, and binding type. And ISBN allows retailer, libraries, and distributors to efficiently search for books. And now, the problem is that mathematics will help us to find that a number assigned to a book is a valid ISBN number or not. Like this, see here the image. The ISBN number is shown here, that 38805310113. 3 is the last digit. And a simple application of mathematics, a simple application that is of congruence operation will help us to determine that this number is a valid ISBN number or not. So come to the next slide. See, the basic phenomena is to study to comprehend that what is A congruent B modulo n. So that is a simple matter. That means that A congruent B modulo n, this is read as in yellow there, in yellow box, this is read as A congruent B modulo n, and that means A minus B is divisible by n. We all know about, we all have concept of division, so we all know that when we say that A minus B is divisible by n, if for three integers a, b, n, A minus B is divisible by n, then we will say that A congruent B modulo n. A simple matter, like say 10 minus 5, that is 5, is divisible by 5. So we can say 10 congruent 5 modulo 5. That means 10 minus 5 is divisible by 5. So first we should know that. Then the formula to check the validity of an ISBN number is like this. Summation I equal to 1 to up to n I into xi congruent x10 modulo 11. What is this xi? This xi are the digits of this. So this 3 is our first number, that is denoted by x1. This 8 is our second number, this is x2. And in this manner, this x1, x2, x3 up to this 1 is our x9, the digit before the last digit, and the last digit is 3, which is our x10. So what we should check? We should first calculate summation I equal to 1 to up to 9 I into xi. That means 1 into x1, that means 1 into 3, just written here. Then 2 into x2, 2 into 8, like this. 9 into 1, that is 9 into x9. And after calculating this summation I equal to 1 to up to 9 I into xi, we get 102. Now we have to check this 102 congruent x10. x10 means this is the last digit 3. So we have to check this 102 congruent 3 modulo 11 holds or not. So this is 102, and so to check 102 congruent 3 modulo 11, what we have to check? We have to just check this 102 minus 3 is divisible by 11 or not. So this is clear that this 102 minus 3 is our 99, which is clearly divisible by 11. So we can write this 102 congruent 3 modulo 11. That means this summation I equal to 1 to up to 9 I into xi congruent x10 modulo 11 is satisfied. And hence this number is a valid ISBN number. So this is a simple application which is found in discrete mathematics. A student studying in honors course can study this. So in this manner, we can check a number is a valid ISBN or not. Okay, next come to another topic, another application of congruence operation to find UPC. See, what is the meaning of UPC? UPC means universal product code. Every product has a unique code, and that is called universal product code. This is a unique 13-digit number assigned to each individual product sold in stores and online. Now we all see that in every product there is a barcode and also UPC code. It is used to identify and track products as they are sold, shipped and received. So also there is a nice application of congruence operation to check code is a valid UPC or not. So see here, this dairy milk has a unique code like 762201761530, and we can easily check that this code is a valid UPC or not by a simple application of congruence operation. See in the next slide. See here, the formula to check the validity of a UPC is this. We have to calculate first this summation I equal to 1 to up to 12 AI when I is odd, then plus 3 into summation I equal to 2 into I equal to 2 to 12 AI when I is even, plus C means the last digit written beneath this, congruent 0 modulo 10. So we have to check this number. So also here we are denoting xi by the ith digit. That means 7 is our first digit, that is x1, 6 is x2. In this manner, C is our 0, last digit. So first we have to calculate these things. So 1 into this 7 into 1 plus 6 into 3, like this calculation, and we have got this value is our 80, and then this 80 plus C, that is our last digit. 80 plus C, our last digit is 0, so 80 plus C, this is 80. So we have to check this digit 80 congruent 0 modulo 10 holds or not. So for this, what we have to check? We have to check this 80 minus 0 is divisible by 10 or not. So clearly 18 by 10 will be 8. So 80 is divisible by 10. So we can write this 80 congruent 0 modulo 10. That means this summation AI plus summation 3 into AI plus C congruent 0 modulo 10 holds here. So this code, this UPC code is a valid UPC code. In this manner, we can check code, a UPC code is valid or not. Next, come to our next slide. This is an application of trigonometry and physics to a rider or common man who are used to ride cycle or bike. See here, a simple application will give us that a rider should safely bend, that he is bending but he is not skidding. So why? So see in this picture, when a rider is bending like this, so there are some forces. So written here explicitly. So suppose the rider has velocity v and it is rounds the circle of r, radius r. So there are some forces. One force is called centrifugal force, which will be mv square by r, and another force is gravitational force mg. And see here, this there is also a reaction. There is also a reaction, normal reaction. and this yields friction. And for this friction, there are two forces. One is if the friction is R, then the two forces are vertically upwards R cos theta and horizontally R sin theta. So these two forces actually should balance these two forces mv square by R and mg. So this should be equal to keep the cycle balanced. It should be equal that R cos theta equal to mv square by R and R sin theta equal to mg. And after calculating, this should be that theta in which he is bending with angle theta, this tan theta should be less than equal to v square by rg, and then the cycle will be set. So see here, we are not studying physics and mathematics, but we are riding cycle bike and keep us safe. So this is the mystery behind that. Okay, next come to our next slide. This is another application and very interesting application of principle of mathematical induction. Principle of mathematical induction is actually in class 11-12 standard. See, the problem is, see this first. Suppose a Shubham made a hotel having infinite number of rooms in Goa near Candolim beach, and within a few days it becomes very popular, and fortunately at some time all rooms are filled. That is, there is no empty room. No rooms are empty. All rooms are filled. Suddenly, one of his close friends, Subhrajit, came to stay there for one night. Then what Shubham should do? Really a problem? As Subhrajit is one of his close friends, Shubham should allot one room for Subhrajit, and also no family allotted there should be get lost. In such a difficult situation, Shubham is worried and follow this manner, this application of principle of mathematical induction. So to solve this problem, first we have to understand what is principle of mathematical induction. This is like this. Let Pn be a given statement. Pn be a statement which depends on n. N is natural number. So suppose Pn be a statement having two conditions satisfied. Number one is the statement is true for n equal to 1. That is, P1 is true. And number two, if the statement is true for n equal to k, for some natural number k, then this statement is also true for the natural number k plus 1. So then this principle of mathematical induction said that this statement Pn is true for all natural numbers n. So the proof is not written here. This can be in any 11-12 standard mathematics book like SND. So we are just using the application of this induction. So what said that? To prove a statement Pn true for all natural number, we need not to prove Pn is true for like n equal to 1, 2, 3, 4, 100, 200, not like that. We just, if we are given, if we can prove that P1 is true, and we can prove that if Pk is true, then Pk plus 1 is true, then we can say it by this principle of mathematical induction that Pn is true for all natural numbers n. And then in this situation, Shubham will use this principle of mathematical induction, and Shubham will make a statement Pn that what Shubham will do? Shubham will just allot the family which is in room number n. Suppose here, see the picture. In this manner, Shubham first allot the room numbers. So this is number 1. There are written the room numbers in above the door of the room. So this is number 1 room, this is number 2 room, number 3, 4, and in this manner, Shubham made the rooms a number, and then Shubham made that the statement Pn that should be the member who are in room number n. Shubham should allot them in room number n plus 1. So Pn is the statement that the family who are in room number n, that they should transfer to room number n plus 1 in that manner. And using this statement, see first, we should just see that P1 is true or not. That means the room number 1, the family in room number 1 should be sent to room number 2. So P1 is true because this is possible. And then what will be happen? Room number 1 will be empty. So room number 1 will be empty, and also the family members who are in room number 1 are now in room number 2. And then the family members are in room number 2 are also sent in room number 3. And also the family members of room number 3 are now sent to room number 4. And in this manner, Shubham make this statement that the family members are room number k are sent to room number k plus 1. And in this manner, Pn is true. Now P1 is true. And if Pk is true, then clearly Pk plus 1 true. So what we can conclude by principle of mathematical induction, that is Pn is true for all natural numbers n. That means every family members lying in room number n will be in room number n plus 1. That means they will have a room. So no family member should get lost. But also there is room number 1 which is still empty. So Shubham, what will do? Then ultimately Subhrajit can be allotted to room number 1, and also no family will be left out. So by this nice trick, Shubham could maintain the friendship with Subhrajit as well as keep his business up well. So this is a nice, wonderful application of principle of mathematical induction. That is true that in real life, in practical, Shubham cannot make a room having infinite number of rooms. But at least conceptually, Shubham can think a room, Shubham can think a hotel having infinite number of rooms and solve this problem. So in mathematics, actually, we are studying problem of higher dimension like dimension 4, 5, and so on. When we are studying vector space, we are studying vector space of dimension 4, dimension 5, and in fact of dimension infinity. But our eye is not supporting to see dimension 4. So mathematics is mathematics is making our sense to abstract sense, and which surely carry forward us to that ultimate goal. Okay, then up to this topic, now I have discussed, and now let me hand over Shubham to complete the rest of this presentation. Okay, thank you so much.
So first of all, I would like to thank Priyadi for giving me such wonderful chance to talk about some useful applications of mathematics in our daily life. But interestingly, we can't see any mathematical operations, mathematical symbols when we wake up in the morning or when we go for bed. But ultimately, we have to think about the use of mathematics in different aspects. So far, Subhrajit Dey has talked about different notions of mathematical applications. But currently, I would like something on computer theoretic notion. First of all, every day we use Google Map to locate any destination, to reach that destination within short time span. But behind that Google Map algorithm, we can employ the graph theoretic notion, some mathematical operations, mathematical applications to get the nearest way out. So I will start from the application of graph theory in Google Map. So how Google Map works? That's the basic first question. So we will start. So we will start from this graph theory. What is graph theory? Basically, around 18th century, a famous mathematical puzzle had laid down the stepping stone of graph theory. Graph theory is a branch of mathematics dealing with some techniques of computer science. So this graph theory is an important branch of science. Leonard Euler, a prolific mathematician, solved the famous Königsberg bridge problem, a long-standing unsolved problem. So this is the figure of Königsberg bridge. I am not getting into the details of this problem. Basically, there was seven bridge on the Prizl River in Russia. The problem was to cross each of the bridge exactly once and to coming back to the original position. But unfortunately, for the long time, many scientists have tried to solve this problem, but no one had succeeded. Ultimately, Euler came with the solution. He said that this problem can't be solved, and he made the idea of graph theory. In most of the case, new branch has been developed due to the improvement of any positive solution of the previous problem. But strikingly, the exciting branch of this graph theory has been generated through the negative solution of this Königsberg bridge problem. In most of the cases, we have got few different sections through the improvement of previous sections. But in this case, Königsberg problem has not been solved. That's why we got the idea of graph theory. So what is graph? How can we define graph mathematically? It's a very simple thing. There are a few figures given here. Graph theory reveals the relationship between objects through the line. So objects are denoted by dots. In this figure, there are so many graphs and objects are pointed by red dots, and red dots are connected by some lines. So graph means a pair of lines and some objects. That means vertex and some nodes. So vertex are joined through the lines or edges. But what is the application in Google Map? Basically, around 1956, Edgar Dijkstra first gave the idea of shortest path algorithm. Basically, there are so many algorithms, including Prim's algorithm, Kruskal's algorithm, and so many things. But in case of Google Map, we use this shortest path algorithm. So how can we relate this thing into simple day life? Basically, in case of Google Map, we have some destination and we have some starting point, but we are trying to figure out the exact route within short time interval and with short cost. That's why we are using this graph theoretic algorithm. So what we are doing, basically, we have to create some unvisited node list. That means what are the tentative spot or tentative stoppage throughout our routes. That's the first target. Then initialize the distance to 0 for starting node, infinity for others. That means from our initial stage to the first stoppage, our distance will be considered as 0 and infinite for other stoppage. Next, current node will be chosen as unvisited node with smallest distance. That means from starting point to the destination, we have so many stoppages, but for the consecutive stoppage, we are calculating the distance from the original one. If the distance is smaller, then we are proceeding. If the distance is bigger than the previous case, then we will not choose that specific stoppage. So this kind of algorithm has been described through this figure. That means if the current node is our destination, then our search is completed. But if the current node is not our destination, then we will run the algorithm again and again. That means we are trying to find the shortest path. That's why we can choose 5 stoppage. If our distance is not expected, then we will choose another 5 stoppage. So using different kind of stoppage, we are trying to manipulate, we are trying to optimize our time, our cost. So this is the basic idea. But if we give this idea through graph, so what will be the figure? So first case, give the idea of optimum costing. Suppose there are 6 vertex v1, v2, v3, v4, v5, v6. We are trying to figure out the optimum cost to reach v6 from v1. There are so many options, but we have to get the optimum cost. So how is it possible? Basically, this tabular form gives the idea of distance from the original one, and which node has been visited and which is unvisited. That's why for the first row, v1 distance is 0. That means the distance from v1 to v1 is trivially considered as 0. But for the second case, if we go to v3 from v1, then that cost will be 4. And if we go from v1 to v2, that cost will be 9 units. So obviously we are trying to get the optimum cost, that means minimized cost. So obviously we will reach v3. We will not choose the way out for v2 because that cost is much greater than the first case. That's why from v1 we will move into v2. Next, we have so many options. From v3 we can go for v2, we can go for v4, we can go for v5. But if we go for v2, then what will be the total cost from beginning? That will be 4 plus 2, that will be 6. But if we go for v4, that will be 4 plus 1, that means 5. And for the third option, v1 via v3 to v5, that will be 4 plus 6, that means cost will be 10 units. So obviously optimum cost will be 4 plus 1 for the second option. That's why we will consider v1 to v3, then v4. That's why the cost will be optimum. And similarly, after reaching out v4, we have to think about the next target. What will be our next target? We have to reach v6. But how it's possible? If we go from directly v4 to v6, that cost will be 8 units. But if we want to make some break journey, then in that case via v5, that cost will be 4 plus 2, that means 6. So this tabular form gives the idea of optimum cost from this beginning vertex, that is v1 to v6. So initially the cost was v6, initially cost was 6 units for v2. After reaching v3, that cost will be 4. So we will choose this path v1 to v3. Then we will go for v4, that means v1, then v3, then v4. Then v4, we will think about some break journey. We will not go for the direct route from v4 to v6, because in our practical day life, to optimize some timing, to optimize some cost, we can choose some easiest way out via auto. That's why we ignore bus or any kind of other public transport, because auto or taxi is much faster than others, or even we can choose metro. So in every case, we are trying to figure out our break journey planning as well as the optimum cost. So in every case, either seriously or casually, we are using this idea of graph theoretic notion, and Google Map use the shortest path algorithm like this. So this is the way out for optimum cost. And for the second thing, what is the optimum route? So there are 5 vertex A, B, C, D and E. We have to choose the optimum route. How it's possible? So if we start from A, then timing from A to B will be 6 hours or 6 minutes, and timing for A to D will be 1 hour or 1 minute. Suppose hour is our considerable units. So for the first case, timing is 6 hours, and for the second case, timing is 1 hour. So obviously we'll choose this route, that is from A to D. Next, we have to go the ultimate destination. So from D, there are so many alternatives. So from D, the timing to reach B, that will be 2 hours. Timing to reach E, that is 1 hour. But we are trying to get the idea of optimization in every situation, every aspect. So that's why from D, we will move into E. So we have started from A, we have gone to D, and then we will reach E. So ultimately, for the first two cases, the timing is very short. Then reaching after E, what will be our target? We can go for B, we can go for C. But if we go for B, then that distance will be 2 units. If we go for C, that distance will be 5. But ultimately, if we consider alternative options in every situation, we have to calculate what is the previous timing and what is the current timing. So we have to add those things. If the current value is lesser than the previous one, then we will proceed, otherwise we will not proceed. So that's why the tabular form has been mentioned here. So ultimately, in this figure, we can choose the optimum path as A, from A to D, then E to C. So A, D, E, C. This is our optimum route in this type of example. There are so many examples, and we can elaborate this thing in details, but I'm not interested to get in the hardcore computer theoretic idea and complex mathematical notion here. That's why I have given this idea of Discrete algorithm and shortest path algorithm. For the first case, we can apply this graph theoretic notion to get the optimum cost, and for the second case, we can apply the same algorithm to get the optimum route. That's why in case of Google mapping, even in case of Facebook searching or Google page ranking, we can apply this same kind of algorithm to get the nearest link up. In case of Google page rank, if we employ this idea of shortest path algorithm, then we have to get some connections between vertex and edge, that ultimately we are using this kind of algorithm. So we are mentioning some nodes, we are connecting those nodes via some lines or edge, and then we are applying this shortest path algorithm. So this is a fantastic application of mathematics. A graph theoretic application has been mentioned here. Next, I will tell about this important application of cryptography. In everyday life, everyone using WhatsApp. That's an essential social networking platform to communicate friends, relatives, and so many others. But end-to-end encryption has been inbuilt in this WhatsApp platform. Everyone has seen this kind of message when anyone is starting chat with others. That message you send to this chat and calls are now secured with end-to-end encryption. Tap for more info. So that means you are the sender and someone is a receiver. You are trying to send some chat, or you are trying to communicate via some audio calls or video calls, but your communication will be secured under this end-to-end encryption. So what is cryptology? So cryptology is a very important part of our life. We have to know this basic essence of this cryptology, because nowadays everyone is facing the problem from these hackers. But we can't underestimate any kind of hackers, because they are much more advanced from us. So that's why we have to be smart in terms of theoretical knowledge, in terms of practical knowledge. So we have to learn what is cryptology, how can we deal with that kind of attack, how can we keep safe our documents, our data, and how possible the way of communication. That's our target. So what is cryptology? Cryptology is an important scientific branch dealing with security privacy. Cryptos means hidden and logos means the branch of study. So cryptology is the branch of hidden study, that means study of secrecy. So what kind of secrecy? Suppose I am the sender, I want to send some chat with some receiver. So my plain text will be encrypted via some keys. So that means the cipher text is unreadable in general form. So any general public can't read that cipher text because as sender I have encrypted that plain text. So that cipher text will be sent to the receiver, and upon receiving that cipher text, the receiver will decrypt with some personal decryption key. I will say detail what is public key, what is private key. So with the rapid advancement of technology, a large amount of data are being shared every day through unsafe network. So we need to ensure three things basically: confidentiality, integrity, and authentication. So, but what is the use of cryptography in our daily life? But or is there any historical evidence of encryption? Obviously, from very beginning we can see the use of cryptographic, that means code language, from this ancient Egypt hieroglyphics. So these are few figures where we can identify that this A, B, C, D, E, F, that's the Roman alphabets, have been encrypted with some symbols. So using those kind of symbols, they communicated with others. So using this kind of leg shape, they they wanted to mean that letter B. So these are few examples, and obviously we have to mention the use of German Enigma machine. This played a huge role in Second World War. Using this German Enigma motor, German military force has tried to send some essential message to other parts of their force, but ultimately US military force has break down that Enigma motor. So this is very useful item in regards of historical evidence of encryption, and this example is also an historical example. So first line is a very simple plain text: the quick brown fox jumps over the lazy dog. Interestingly, this plain text contains each of the 26 alphabets from A to Z. So this is our plain text, but we are trying to hide the exact text from the general public. So we need some technique, we need some cipher text. So what will be the cipher text? Roman Emperor Julius Caesar used this idea of Caesar cipher. So what was the technique? Basically, he used the rightward shift by 3 position in his military force for the communication. So in this case, we can observe that the first letter T has been substituted by Q. That means the T has been substituted 3 position rightwards. So after T, sorry, it's not 3. Okay, so that's my fault. Basically, in this case, cipher text has been formed using leftward shifting. That means if we count the previous 3 letters from T, that will be Q. So T will be substituted by Q, H will be substituted by E, and E will be substituted by B. Because if we start from B, then what are the next alphabets? C, D, and E. So from E, we will make the leftward shift 3 positions. That's why E has been shifted by B. Similarly, Q has been shifted by N, U has been substituted by R, I has been substituted by F, and so on and so forth. And similarly, for the last word, D has been substituted by A, O has been substituted by L, and G by D. So this is the idea of scissor cipher. That means we can use 3 place right words, 3 place left words. So this is the idea of scissor cipher. But this is very easy to break. That means there are finite 26 alphabets. So easily we can anticipate those kind of combinations. So this kind of ciphertext is very easy to break. So nowadays this ciphertext is very much obsolete. So we can't use this kind of hieroglyphs application. We can't use this kind of enigma motor idea and this kind of scissor cipher. So what are the other examples of encrypting techniques? So this is another technique. This is known as columnar transposition. So for this first case, my given text is gigs for gigs. I want to make this text into the unreadable form. That means I am trying to get some encrypted text or some cipher text. That means which is unreadable by the general public. General layman can't get the clue of my given text. That's why I am trying to encrypt my given text. So how is possible? So using this columnar transposition, suppose my keyword is hack. So this is my special information. So what are the length of this keyword? There are 4 letters in this word. So that's why I have made this table hack. But if we consider this alphabetic ordering, then A will be treated as 1, C will be treated as 2, H will be treated as 3, and K will be treated as 4. Because as per alphabetical ordering, we will give this numbering 1, 2, 3, and 4. So this hack is my chosen keyword. Using this keyword, I will encrypt my given text gigs for gigs. So how it's possible? So there are 4 letters and gigs for gigs. That means ultimately 16 letters are there in my given text. So I have written gigs for gigs with this specific space in this tabular format. That is GEEKS space, then for, that is FOR, then space GEEKS, then again space. So ultimately 16 positions have been specified here, and I want to encrypt the whole text into some unreadable form with my keyword hack. How it's possible? Firstly, this is one coming from A, 2 coming from C, 3 coming for H, and 4 coming for K. So ultimately we will start from the first numbered column. So from down using this downwards arrow, we are trying to give the idea of encrypting text. That means through this downwards arrow, we are get the idea of E space K. This is the first phrase. For the second column, we will again use this downwards arrow. That means E F G S. This is our second phrase. What will be the third phrase? We will go to the third numbered column. Not necessarily third column, but we will choose the third numbered column. So depending on this alphabetical algorithm, we will got the idea of exact phrase. So for the first phrase, we have chosen this second column. For the second phrase, we have chosen this third column, that is 2 numbered column. And for the third phrase, we are choosing this first column, that is GSRE. And for the last phrase, we can get K, O, E and space. So ultimately we have got 4 phrase. So 4 phrase, 4 position. So ultimately 16 letters or 16 positions have been specified. In my given text, gigs for gigs with some space, there are 16 positions. Ultimately, using this hack keyword, I have made this encrypted text. So what is my encrypted text? The text is quite blurred, but I am saying that encrypted text is E space K E F G S G S R E K O E space. So using this kind of columnar transposition, it is quite hard to anticipate my exact given text. So it's very difficult to hack the plain text sent through the sender to the receiver. So this is one kind of encryption technique. What are the other simple techniques? For the second techniques, this is known as monoalphabetic substitution. So why monoalphabetic? Mono means single. So we will substitute each letter with some specific techniques. So there are 26 alphabets from A to Z. So if we break A to Z into 2 parts, so first part will have 13 letters, for second part will have 13 letters. So ultimately, using that rotation of 13, we can use this monoalphabetic substitution. So using that 13 positional rotation, we can change the word hello by URYYB. That means the first letter H has been substituted by U, E has been substituted by R, L has been substituted by Y, and similarly O has been substituted by B. That means if we try to encrypt our simple plain text, then we will use this kind of monoalphabetic substitution. That means each letter will be substituted rightwards or leftwards 13 positional alphabets. That's why H has been substituted by U. So this is another simple techniques, because nowadays we are getting different kind of frauds, different kind of attacks through our ATM transaction, online transaction, different kind of situations. So we can't use this kind of simple text at all. Even in case of WhatsApp, if we make this backup button, if we press this backup button, then we will see that that backup folder will have some name, that EK4153BD, so on and so forth. That name is not very clear to our general mass. That means we can't easily trace the original item in that backup folder. That's why this end-to-end encryption system is inbuilt is our WhatsApp system. That's why WhatsApp is quite safe rather than any kind of social media platform. So this is another encryption technique which is known as monoalphabetic substitution. And using some mathematical matrix multiplication, we can encrypt and decrypt our text. Even computer does not have any knowledge of any plain text. The machine will only have the idea of 0 and 1 bits. Computer will only know 0 bits and 1 bits. So our plain text has been converted with some numbers. The machine only performs with some bitwise operation. That means only depending on 0 and 1. So ultimately we have to get the idea of numbers. There is no practical application of text cipher. These are few examples to get the idea of encryption and decryption. That's it. But this kind of encryption is not useful in our daily present situation. So that's why we have some stronger algorithms. But before going into that, I want to say what is Hill cipher. Basically, cipher text will be computed using this operation. That means plain text will multiply by some key numbers mod 26. Mod 26 means the ultimate number will be divided by 26 and we will get the simple remainder. So depending on that remainder number, we will choose the exact letter. So if we observe this last phrase of this figure, that is hill, Hill. So Hill, and if we consider the alphabetical ordering of those numbers, then we will get that Hill will be treated as this matrix form, that is 7, 8, 11, 11. So these are the alphabetical ordering number, and my key is MP. This is my chosen key. Using that key, I want to encrypt my plain text. So what will be the corresponding numbers of M and P? That will be 12 and 15. So we will make some matrix multiplication. That means 7 times 12 plus 8 times 15. So first number is 204, and for the second row and this column, 11 times 12 and 11 times 15, that number is 297. But we will use the modular 26. So what is modular 26? That means 204 and 297 will be divisible by 26, and we will choose only the remainder. So the remainder will be simply 22 and 11. So what will be the corresponding alphabets? The corresponding alphabets will be W and L. So our plain text was hill, Hill. That means the mountain. That was my plain text. But what is the cipher text? The cipher text is WL. So using this kind of matrix multiplication, we can encrypt simple plain text into some unreadable form. And this is another example. This is known as OTP. So my plain text is meet me outside. So the corresponding number, numerical position have been mentioned here. That is, E will be treated as 4, M will be treated as 12, T will be treated as 19. So this is my numerical plain text. And what will be the OTP? In case of ATP transaction or online transaction, every time we get some OTP. That means one-time pad, which can be generated through some random number generated. So that is totally random. There is no specific anticipation previously. So we can't anticipate this exact OTP previously. So suppose the random OTP is B, D, U, F, G, H, so on and so forth. So the corresponding numerical position have been mentioned here. That is 1, 3, 2, 25, 6, so on and so forth. So why B will be treated as 1? Because A will be treated as 0 and Z will be treated as 25. Because from A to Z, 26 alphabets. So we will consider 0 to 25. So that's why this is our numerical position for this OTP. So we will simply add those numerical numbers. That is 12 plus 1, 13, 4 plus 3, 7, 4 plus 20, 24, 19 plus 5, 24, 12 plus 16, 18, so on and so forth. But in this case also, we will apply the modular 26 operation. That means if any sum is bigger than 26, then we will divide it by 26 and we will consider the exact remainder. If we consider this one, 18 plus 20, the sum will be 38. But if we divide it by 26, then remainder will be 12. That's why this numerical ciphertext is simply 12. So depending on this numerical position, we can get the ciphertext N, H, Y, Y, S, L, K, Y, B, M, N, G. But my plain text is very simple. That is meet me outside. But I have used this one-time pad encryption. So using this OTP encryption, my ciphertext is quite unnatural. It's not easy to anticipate the exact plain text. And another random example. Suppose my ciphertext is CSYLEZIFIIRWIPIGXIG. But we have to break the ciphertext and we have to get the idea of exact plain text. So what will be the possibility? Basically, it's not very simple to give this answer within very short time. We have to check some techniques. But this is very simple techniques. I have mentioned already about the scissor cipher. That means 3 plus rightward shift or 3 plus leftward shift. I have mentioned the idea of monoalphabetic substitution. That means each letter will be substituted by 13 positional alphabets leftwards or rightwards. But in this case, C, this first letter has been shifted 4 place leftwise. So there was a left shift 4th place. That's why C has been converted with U, S has been converted with O, Y has been converted with U. So this cipher text has no specific meaning, that is CSY, LE, ZI, FIIR, so on and so forth. But plain text have some specific meaning. And plain text is very simple, that is you have been selected. So if we apply the 4th place right shift, then we will get this kind of ciphertext. That means Y will be substituted by the letter C, because after Y there is only Z, A, B. So after B, that 4th position will be C. So Y will be replaced by C, O will be replaced by S, U will be replaced by U. U will be replaced by Y, because after U we have V, W, X, and 4th item is Y. So that's why U letter will be replaced by Y. So this is a random example of encryption. So this kind of encryption is useful to keep safe our daily life data. But in case of WhatsApp, the end-to-end encryption use quite complex algorithm. So WhatsApp employs open source signal protocol for the construction of end-to-end encryption. The protocol mainly make use of this curve, that is curve 25519. So the mathematical equation of some curve can be expressed as y square equals to x cube plus 48662 x square plus x over some prime field defined by this number. So what is prime field? We have the idea of prime numbers. So what are the prime numbers? 2, 3, 5, 7, 11, 13. These are prime numbers. Those numbers have no exact dividers except 1 and that number itself. So depending on that prime field, this kind of curve is being used in the end-to-end encryption in WhatsApp. But this idea of end-to-end encryption is not very old. Daniel Bernstein proposed this idea around 2005. So this is quite modern, because we can't use the idea of scissor cipher in this modern day, because everyone will anticipate the exact plain text or will break the ciphertext. That's not the smart technique at all. And WhatsApp use this Diffie-Hellman key exchange. I will give this brief, very short idea of this key exchange. Suppose this man trying to give some, the first one is trying to send some data or some text with some receiver. So first one is sender, second one is receiver. So first one private key is 5 and 4 is the private key for the second one. They are trying to communicate with each other. But what is Diffie-Hellman key exchange? Using this key exchange, they are trying to check whether anticipated by any third unauthorized person or shared secret is same, then their communication will be fine. So they initially agreed upon two numbers, that is prime number is 13 and generator of P is 6. So these are their personal information. 5 is the personal information for the sender and 4 is the personal information for this receiver. So first one computes 6 to the power 5 with respect to this prime number mod 13. So what is the output? Mod 13 means we will get the remainder itself. So the remainder is simply 2 So he or she distributes this public key over this public channel. So over this public channel means there are so many unauthorized persons between this channel, between this sender and receiver. So each unauthorized person is trying to anticipate the exact private key of the sender and exact private key of the receiver, so that they can anticipate the exact plain text. So first one shared the public key 2, and second one computes 6 to the power 4 with respect to mod 13. So what will be the remainder? Remainder is 9. He shared this 9 over the public channel. So he shared 2, he shared 9. So upon receiving this 9, he computes 9 to the power 5, because her private key was 5. That's why she computed 9 to the power 5 mod 13, and he computed 2 to the power 4 because his private key was 4. That's why he computed 2 to the power 4 mod 13. But ultimately, in each case, shared secret is 3. So shared secret of the sender is 3, shared secret of receiver is 3. That means distributing this public key over this unauthorized channel or unsecured networks, there is no anticipation through some unauthorized person. So that's why this shared secret gives the authentication of this end-to-end encryption. So this is very rough idea of end-to-end encryption in WhatsApp. I am not giving any complex idea of further extension of this end-to-end encryption. But in case of visual encryption, if we apply this encrypted technique for any kind of image or any kind of video, audio, so what are the figures look like? That's why I am giving 4 examples of 4 image. So suppose this is my plain text image. That means this is my original image, and I want to send this image to some receiver over some unsecure networks. So I want to hide the exact objects or exact detailing in this image. So that's why I will apply some encryption techniques with this object. So after applying say, very small amount of algorithm, the figure looks like this. After several rotation, the figure will be blurred, and for the final stage we will get this kind of cipher text. So this was my original text. After several rotation or several application of encryption, we will get this kind of random outputs. This is quite random, but this is cipher text. So getting this cipher text is very difficult to anticipate the exact objects or exact detailing in the original image. So this kind of visual encryption is quite practical and quite essential in our daily life application, because we are communicating with the persons with so many data, so many files, so many audio, video, image, PDF, so on and so forth. So every time we have to communicate over some secure networks, but secure network is not very easy to access. That's why we have to be smart, we have to careful about the encryption. We should not share our OTP, or we should not share our personal basic informations, because our CVV numbers, our ATM password, our PIN codes, these are the exact private keys for key exchange. So this private key 5 is same as our ATM CVV number or our ATM OTP. So we should not share this kind of private information with any kind of unauthorized. In that case, that unauthorized person will break our system and we will face some unexpected situation. So that's why from WhatsApp or Google, Gmail, or any kind of LinkedIn or social media platform, we have to be careful. This is some general applications of encryption These are few examples of cryptography. These are very mathematical. I have not said anything about computer algorithm at all. These are completely mathematical. So these are few basic mathematical applications in our everyday life. So that's all, and I think it's all for today's lecture, and already I have skipped the specified time limit, so sorry for that.
Not at all, not at all. In fact, it was really, really interesting and enterprising to listen to all this. I mean, there's so much that we use, and especially this end-to-end encryption thing. I had no clue there was such a trick hidden behind. I would always wonder what makes an end-to-end encryption. So that was a mystery till date. But thank you, both of you. It was wonderful listening to the session, and very interesting, very quirky, very day-to-day stuff that involves maths, and still wasn't aware of that. I
A
just
big
want
thank to you
one.
for giving us this wonderful chance.
No, no, absolutely. It's a pleasure for you and Thee to have y'all, for y'all to take out time, prepare this, and come and present. I think we are the ones who are the lucky ones. So thank you. I just have a very small, quick question. With all this AI and computer coding and everything, where is pure mathematics as a subject of study featuring in youngsters nowadays? How do you see the future of just absolutely pure mathematics? Because what I see here is, maths is the backbone for all that we are doing and engaging into, from data to AI to security stuff. There's a lot of maths that stays behind it. So what are your guys' opinion about it? What do you think uh, as to where is mathematical, pure general mathematical studies heading towards, with newer subjects like AI and computer languages and coding and everything is coming in? So yeah, if you can say a few things about that.
Shubhrita, if you can start with this.
Actually, Shubham said about this end-to-end encryption in WhatsApp, and this is actually coding decoding theory, which is an application of abstract algebra. Probably Shubham know better from me. This is actually application of pure mathematics, abstract algebra, and actually there are so many such aspects where pure mathematics are being applied, but it's very difficult to find a connection that pure mathematics will be applied directly. It is already applying, and hardcore mathematics are worked, but need to take time for world to accept pure mathematics directly applied. Probably. And Shubham say something.
No,
Actually, what we think that probably world is not prepared today to accept pure mathematics to apply directly in some branch.
Where do you think is the glitch? Where do you think is the hurdle standing? Where exactly is the misconnect, if I may ask?
That is actually a very difficult question, and the people who are just working to connect this type of connection. Recently, mathematics is applying to music therapy to in directly in biology, directly in biomathematics. So that researcher probably get better answer who are connecting this from pure mathematics to applying mathematics like this.
Also, there's another question that I have is, so if we go back to all the great mathematicians who have done some remarkable findings from, let's take an example of Bertrand Russell. He's one name that I can remember of, who who was a great philosopher also of his many. He is known as as one of the greatest philosophers of his time. So, do you think that every great mathematician or a renowned mathematician is also a deep philosopher? Is there a connection between the two? Are they too much interlinked? Is it necessary for a good mathematician to also be a philosopher? Um, hand to hand.
I I should not answer this question because I am not like that a great mathematician. But I believe this is true. Believe that strongly. I believe that
Right.
because in this abstract sense probably can be made by mathematics only. That I am saying there that we are studying higher dimensional problems, like we are studying vector space of dimension 4, 5, like that, and there is the existence of dimension 4, but our eyes limit are only 3. We cannot see any dimension higher than 3. We are only 3 dimensions. We are in 3 dimensional space and we see only 3 dimensional matters. Our It's our limit, but we are studying higher dimensional problems. So only mathematics can make this abstract sense.
That's a lovely thing for a mathematician to say. That's
Sure.
it's amazing. So thank you so much, both of you, once again, Dr. Subhrajit Dey and Mr. Shubham Mukherjee. It was an immense pleasure listening to you all, to be able to host you all today at UinDhi. Thank you so much.